Hello and welcome once again. Today we are going to be looking at the 2019 chemistry JAMB question. So we're going to be looking at the question. I will display the question and then I'll ask for the feedback, which I expect you to put in the comment section. And thereafter, I will review the answer and explain the reason why that answer was chosen. So that's the system we're going to be using, just like what we've been using previously. I just need to just say it again, so that we can be on the same page and understand how the flow will be like. So we start with the first question now. And the first question from the 2019 chemistry jam question is this. It says, a secondary alkanol can be oxidized to give, is it an alkanone, an alkanal, an alkanone, an alkyne, alkanoic acid, or alkanal. So you tell me what you feel the answer is in the comment section, and I'll reveal the answer to be this, which is an alkanone. So a secondary alkanol can be oxidized to give an alkanone. That's the one with the functional group of C double bond O. So when you have a secondary alcohol or alkanol, you can oxidize it to give us what? An alkanone. So let's take note of that. Basically, a secondary alkanol, which is a secondary alcohol, has the hydroxy group OH attached to a carbon that is bonded to two other carbonate atoms. Upon oxidation, it cannot form an aldehyde or carboxylic acid because there is no hydrogen on the carbon bearing the OH group. Instead, it forms a ketone, which we also call an alkanone, where the carbon of the OH group becomes a carbonyl group. That's the C double bond O between two acyl groups. So the answer there is an alkanol, and that's the reason why we have it as an alkanone. The second question says that which of the following will give a precipitate with an aqueous solution of copper 1 chloride? Which one we give a precipitate with an aqueous solution of copper 1 chloride? Is it a but2 in, a but1 in, a but2 ine, or a but1 ine? So looking at all the options that we have there, the right answer to this one is, don't forget, put your own, what you feel the right answer is in the comment section. I'll look at them, then you can also compare it with what I'll be revealing as the answer to the question. So the answer to this question is actually option D, which is a but1 ine, and an alkene, an alkene. That's with a triple bond now. And the reason for that is because only terminal alkynes like but1-ine can react with ammoniaca copper 1 chloride solution to form a reddish brown precipitate of copper 1 alkyne complex. Internal alkyne and alkenes like so and sorry, I had a network glitch, so it's cut me off temporarily. So what will happen is that I'll start all over again from question one, and then I'll move along. Hopefully the network will be stable all through till the end. Okay. So we start again from question number one. Just a minute. Let's do this. Okay. Okay, so let's start again from question one. And it says a secondary alkanol can be oxidized to give and is it alkanone, alkyne, alkanoic acid, or alkanal? Okay, so the answer to this question is actually option A, alkanone. And the reason why it is alkanone is because a secondary alkanol or how a secondary alcohol has the hydroxyl group OH attached to the carbon or to a carbon that is bonded to two other carbon atoms, you know. So upon oxidation, it cannot form an aldehyde or carboxylic acid because there is no hydrogen on the carbon bearing the OH group. Instead, it forms a ketone, that is an alkanone, where the carbon of the OH group becomes a carbonyl group. That's a C double bond O between two acyl groups. So that's the reason. So the option there is option A. The second question says that which of the following will give a precipitate with an aqueous solution of copper 1 chloride? Is it butsuine or but1-ine or butsuhine or but1-hine, as the case may be? The answer to this one is actually but1-hine, D, option D. And the reason is because of the terminal nature of the what's it called? The terminal nature of the functional group in but1-hine. That's the triple bond, you know, C double bond, triple bond that we have, you know. So basically only terminal alkynes like but1-hine can react with ammoniacal copper 1 chloride solution to form a reddish brown precipitate of copper 1 alkyne complex. So internal alkynes and alkenes like butsuine and butene do not react this way. So the only one that can go is the terminal alkyne like but1-hine. So let's take note of that. The third question says that the IUPAC name of CH3, the IUPAC name of CH3, CH2, COO, CH2, CH3 is it methyl propanoid? Is it ethyl ethanoid? Is it ethyl propanoid or methyl ethanoid? And the answer to this one is actually C, ethyl propanoid, ethyl propanoid. And how did we arrive at this? Basically, this is it. This is an ester. It's an ester. Ethyl propanoid is an ester made from the reaction between propanoic acid and ethanol. Now, the acid part contributes to the propanoid's name, where the alcohol part contribute to the ethyl prefix, you know. Thus, the correct IUPAC name is what? Ethyl propanoids. Ethyl propanoids. So that's the correct IUPAC name. Okay. Moving on to the next one. A certain hydrocarbon on complete combustion at STP produce 89.6 dm cube of CO2 and 54 grams of H2O. The hydrocarbon should be, is it benzene C6H6? Is it butane C4H10? Is it pentane C5H10? Or I think butane now. Butane, yes, C4H butane, yeah, butane, not butane. Butane C4H6. So let's look at it. The answer is C4H10, which is butane. Now, why is now? How did we arrive at this? 89.6 dm of CO2 at STP equals to 89.6 divided by 22.4. How did we get 22.4? 22.4 is just the molar volume at STP, you know, 22.4 dm cube. So what we have there is 4 mole. That will be equals to 4 mole. It connotes that the hydrocarbon contains what? 4 carbon atoms. It contains 4 carbon atoms. Having established that, the next one is 54 gram of water. Now, 54 grams of water, you divide it by the molar mass of water. Hydrogen is 2, oxygen is 16. 2 plus 16 will give us 18. So 54 divided by 18 will give us 3 moles. This 3 moles of water contains 6 hydrogen atoms. Since water has 2 hydrogen per molecule, therefore the molecular formula will be C4H10, a saturated alkane. So that is how we arrived at that. Okay. So we move on now. It said 2-methyl prop-1-ene is an isomer of 3-methyl but 1-ene, 2-methyl but 1-ene, both 2 in or pent 2 in? The answer here is both 2 in. 2-methyl prop 1 in is an isomer of both 2 in. And we arrived at 2-methyl prop, prop 1 in and both 2 in both have the same molecular formula, C4H8. That is the same number of carbon and hydrogen atoms, but differ in their structures. So we have 2-methyl prop 1 in as a branch structure, but both 2 is here with a double bond between carbon 2 and carbon 3. Now, this makes them to be structural, that's chain and position isomer. They are structural, isomers. So they are both isomers for that reason. The question says that hydrocarbon that will react with Tolin's reagent conforms to the general formula CnH2n, CnH2n plus 2, CnH2n minus 2, CnH2n plus 1 OH. Okay, so it conforms general formula, it will conform to CnH2n plus 1 OH. And basically, Tolin's reagent is used to dictate aldehydes and oxidize primary alcohols to aldehydes of acids, hydrocarbon of the form CnH2n plus 1OH are alcohols, especially primary alcohols. Now, which upon oxidation can give aldehydes. Hence, they react with Tolin's reagent. Alkanes, and alkynes do not react with it. So the option A to C, which is the one that are represented with the CnH2n, CnH2n plus 2, CnH2n minus 2, they cannot react to Tolin's reagent. So the only one there is the alcohol, which is the general formula CnH2n plus 1 OH, that can actually react with the Tolin's reagent. Okay. All right, so the next one says that the IUPAC name of the compound CF3CHBrCl is 2-chloro, 2-bromo, 1,1-trifluoroethane, 2-chloro, 1,1,1-trifluoroethane, 1-bromo, 1-chloro, 2,2,2-trifluoroethane, 1,1,1-trifluoro, 2-bromo, 2-chloroethane. Now, we have to be very careful when naming these. We look at the alphabetical arrangement of the substituents, and then we look at the mother chain, the number of carbons that are there, and then that would help us, will guide us in naming and also in putting them in the right position, whatever the substituents are. So the right answer to this one is actually 2-bromo, because B comes before C. So you have 2-bromo, 2-chloro, 1,1-trifluoroethane, and that's B. So the longest carbon chain has 2 carbon established, that's ethane. Carbon 1 has 3 fluorines, that is trifluoro. Carbon 2 has bromine and chlorine. Halogens are listed alphabetically. Bromo, then chloro. So 2-bromo, 2-chloro, 1,1,1-trifluoroethane is the right answer. Okay, moving along now. A synthetic rubber is not obtained from the polymerization of neoprene, isoprene, butadiene, or hexadiene. So synthetic rubber is not obtained from the polymerization of, not, keyword, not obtained from the polymerization of, is it neoprene, isoprene, butadiene, or hexane? The answer here is hexane. The answer here is hexane. Now, the reason is because synthetic rubbers are made from unsaturated hydrocarbons like butadiene, isoprene, and neoprene that can undergo polymerization. Hexane is a saturated hydrocarbon, an alkane, and cannot, polymerize to form rubber. So it's the odd one out there. Okay, so we move on now to the next one. Says that burning magnesium ribbon in hair removes which of the following? Oxygen, nitrogen, argon, carbon 4 oxide. Is it 1 and 4? 1, 2, 3, and 4 only? 1 only, or 1 and 2 only? Now, the answer to this one is actually this, D, 1 and 2 only. Now, because burning magnesium reacts with oxygen, it will form magnesium oxide. Nitrogen will also react to form, magnesium nitride. Now, it does not react with argon, which is a noble gas, or CO2 under normal conditions. Thus, only oxygen and nitrogen are removed from the air. So let's take note of that. Okay. Which of the following is the best starting material for preparing oxygen? Ethane triazonitrate 5 with A, lead, B, zinc, C, calcium, D, sodium. The answer to this one is lead. You eat it with lead. And the reason is because lead triazonitrate 5 decomposes easily upon eating to produce oxygen gas. Other metal nitrates, especially alkaline metals like sodium and alkaline earth metals like calcium, decomposes less readily and may not give oxygen directly. So that's just a distinction there. Okay. Okay. So which of the following metals is the most essential in the regulation of blood volume, blood pressure, and osmotic equilibrium? Which of the following metals is the most essential in the regulation of blood volume, blood pressure, and osmotic equilibrium? Is it zinc? Is it magnesium? Is it sodium or iron? Now, the answer to this is actually sodium. Now, the reason is because sodium ion are crucial electrolytes in the body that help regulate osmotic pressure in cells and tissues. Now, to maintain fluid balance and blood pressure, sodium ion is also very important. It also helps in facilitated nerve impulse transmission. And for zinc and manganese, they are trace elements. Iron is vital for oxygen transport, not fluid regulation. So that's the distinction. So the answer there is sodium. It helps in regulating blood volume, blood pressure, and osmotic equilibrium. Okay. All right. So the next one says that which of the following alkaline earth metals reacts more spontaneously with water? Is it calcium? Is it beryllium? Is it magnesium or strontium? Now, the answer to this one is strontium. And the reason is because of the fact that if you look at the reactivity of alkaline earth metals, their reactivity increases down the group in the periodic table. Therefore, the order of reactivity is beryllium is more reactive than sorry, beryllium is less reactive than magnesium. Magnesium is less reactive than calcium. Calcium is less reactive than strontium, and then strontium is less reactive than what barium. So that's the sequence. So thus, strontium reacts more spontaneously with water than the other listed elements. Okay. So the next one says that when chlorine water is exposed to bright light, the products formed are aqueous HCl and chlorine, HOCl, hypochlorite 1 and chlorine, HCl and oxygen, HOCl and oxygen. So what is the product formed now? And the product form is HCl and oxygen. Now, the reason is this, and it's even given as an equation here. When you expose it, sunlight decomposes chlorine water. And when it decomposes, it will give us 4HCl and oxygen. This is a photochemical reaction where oxygen gas is liberated and chlorine is reduced to HCl. So let's take note of that. So the next question says that which processes is or involved in turning starch iodide paper blue-black by chlorine gas? Is it chlorine attacks the starch to give the blue-black color? Chlorine attacks the iodide ion to give the blue-black color. Chlorine oxidizes the iodide ion to produce iodine, which attacks the starch to give the blue-black color. Or iodine attacks the starch to give the blue-black color. Now, the right option is C. Chlorine oxidizes the iodide ion to produce iodine, which attacks the starch to give the blue-black color. So that's the right option there. And the explanation basically is that chlorine is a strong oxidizing agent. So it oxidizes iodide ion to iodine, and then the free iodine then react with starch to form a blue-black complex. This is a classical test for oxidizing agents. Okay. 15 says that which of the following is a set of neutral oxides? Which of the following is a set of neutral oxides? Is it Option A, option B, option C, or option D? So let me know what you feel the answer is in the comment section. So you let me know what you feel it is in the comment section while I review the answer from here to be option A. And the reason for that is because neutral oxides are oxides that do not react with acids or bases. Examples of neutral oxides include N2O, dinitrogen monoxide, H2O, water, CO, carbon monoxide, SO2, and SO3 are acidic oxides. And then Na2O is basic, ZNO is amphoteric, NO is a neutral radical oxide, but often considered, borderline, so to speak. So the right option there is option A, which is the N2O, H2O, and CO. Okay. On to the next one. SO3 is not directly dissolved in water in the industrial preparation of H2SO4 by the contact process because SO3 is an acidic gas. B, acid is usually added to water and not water to acid. The reaction between SO3 and water is violently exothermic, and then SO3 does not dissolve readily in water. Okay, so the right answer, please let me know in the comment section what you feel the right answer is. Okay. All right. So the right answer, I'll review my own answer to be C. The reaction between SO3 and water is violently exothermic. So SO3 is not directly dissolved in water because the reaction between SO3 and water is violently exothermic. Okay, so if you look at it, in the contact process, direct dissolution of SO3 in water is avoided because the reaction is highly exothermic and forms a dense mist of sulfuric acid, which is difficult to condense. Instead, SO3 is absorbed in concentrated H2SO4 to form oleum, H2S2O7, which is then diluted to produce what? H2SO4 safely. So that's the sequencing. So we should take note of this so that we get the whole yes, so we get it. So that's the reason why that is done. So I want to move on now. I want to move on to the next one, which is option question 17, if I'm correct. Which of the following statement does not represent Rutherford's account of nuclear theory? An atom contains a region which contains protons and neutrons. B, which is positively charged. An atom contains a region which is positively charged. An atom, C, an atom contains a region which is massive and can cause deflection of a few projectiles. And an atom contains a region which is very large and in which close to 98% of projectiles pass undeflected. So the answer to this is actually option D. And it's because an atom contains a region which is very large in which close to 90% of projectiles pass undeflected. So that's the answer to that one there. Question 18 says that elements X and Y have electronic configuration of 1s2, that's for X, 2s2, 2p4, that is oxygen, 6 electrons. Y, 1s2, 2s2, 2p6, 3s2, 3p1, that is aluminum, 13 electron. So when they combine, the formula of the compound formed is it XY, S2Y, Y2X3, S2Y3. So the answer to this, when you have these two combining together, what do we have? What we tend to have is a Y2S3, like we have in Al2O3. So oxygen X needs 2 electrons to complete octets, and the valence is 2. Aluminum Y donates 3 electrons with a valency of what? 3. To balance the charge or the charges, you have 2 Al3 plus 3 O2 minus to give us Al2O3. So the correct formula is Y2S3. Okay. By what amount must the temperature of 200 cm cube of nitrogen at 27 degrees Celsius be increased to double the pressure if the final volume is 150 cm cube? So we have to do a little calculation here. So we need to work it out. And let me review the answer, then I will explain it. The answer is 177 degrees Celsius. And the explanation basically is we use combined gas law, which is P1 V1 over T1, which goes to P2 V2 over T2. And we let the initial temperature to be 27 degrees Celsius, which will be equals to 300 Kelvin. How did we get that? 27 degrees Celsius plus 273 will give us 300 Kelvin. So our P2 equals to 2P1. So therefore, P1 multiplied by the volume, 200, divided by the temperature, T1, 300, equals to 2P2 multiplied by 150 over T2 over T2. Okay, don't forget that the reason why we are saying our P2 is 2P1 is because it said it is increased to double the pressure if the final volume is that. Don't forget, we got that from the question. So therefore, our T2 will be equal to 2 multiplied by 150 times 300. So after we have done a cross multiplication, divided by 200. So that'll be 450 Kelvin. So T in degrees Celsius will be 450 minus 273, and that will give us 177 degrees Celsius. Okay. The combustion of carbon 2 oxide in oxygen, that is, like what we have there, if it's the same cube of CO is exploded with 100 cm cube of oxygen, what is the volume of the resulting mixture? Is it 75 centimeter cube, 125 centimeter cube, 100 centimeter cube, or 50 centimeter cube? Now, we need to also work it out, but what we'll have after working it out is about 125 cm cube. Make sure you work it out on your own. But I will explain how we arrived at that. Now from the equation 2CO plus O2 to give us 2CO2. Now, 2 volumes of CO react with 1 volume of what? Of oxygen. 50 cm cube of CO needs 25 cm cube of oxygen. Now, CO2 formed equals to what? 50 cm cube. Unused oxygen will be what? 100 minus 25, which is 75 cm cube. Therefore, the final volume will be equal to what? 50 cm cube of CO2 plus 75 cm cube of unused oxygen. When we add it together, we'll end up having what? 125 cm cube. So that is how we arrived at that particular answer. So let's take note of that. Okay. Moving along now, when ammonia and hydrogen ion bond together to form ammonium ion, the bond formed is called an electrovalent bond, a compound bond, an ionic bond, or a covalent bond. So let me know what you feel the answer is in the comment section, please. Okay, the answer to this one is a covalent bond. So when ammonia or nitrogen and hydrogen when ammonia and hydrogen ion bond together, they form ammonium ion. The bond formed is a covalent bond. And basically, in ammonium ion, the lone pair of electron on nitrogen is shared with hydrogen ion, which has no electrons. And this is a dative covalent bond, a type of covalent bond where both electrons come from one atom. Though it is often called coordinate bond, it still falls under covalent bonding. So let's take note of this. Very, very important. Okay. This one says that which of the following represents the kind of bonding present in ammonium chloride? Which of the following represents the kind of bonding present in ammonium chloride? Is it ionic only? Is it covalent only? Is it ionic and covalent or dative covalent? Okay. The answer to this is ionic and covalent. Ionic and covalent. That is what you have existing. And basically is because ammonium ion has covalent and dative bond within it. Ammonium and chloride ion are held together by ionic bonding. So the compounds show both covalent and ionic bonding. Okay. Consider the reaction. A in the solid state plus 2B in the gaseous state, if a reversible reaction to give us 2C, which is aqueous plus D in a gaseous state. What will be the effect of a decrease in pressure on the reaction? Is it A, the equilibrium will shift, B, rate of forward reaction will increase, or C, rate of backward reaction will increase, or rate of forward and backward reactions are not affected. So which is the right option for us here? Is it option A, option B, option C, option D? So please let me know in the comment section which you feel is the right option here. Okay, so the answer is A, that equilibrium will shift. And the basic explanation is that according to the Le Chatelier's principle, decreasing the pressure favors the side with more gas molecules. So when we have the left-hand side, we have 2 moles of the gas, that's B. And the right-hand side, we have 1 mole of gas, which is D. You understand? So when you look at the two sides of the reaction, so decreasing the pressure shifts equilibrium towards the side with more gas. That is left, which is backward. But overall, equilibrium with what? Will shift. Equilibrium will shift. Okay. All right, see, so we look at this one. For the general equation of the nature SP, YQ, that's Y is just like the coefficients, then giving us that the expression for the equilibrium constant, is it option A, option B, option C, or option D? Okay, so the right answer to this is option D. Is option D. Now, why did we choose option D? The equilibrium constant expression is always Kc, which equals to products. That's the concentration of the products over the concentration of the reactant, each raised to the power of its stoichiometric coefficient. Hence, our Kc will be equals to what? R raised to power m, and then the concentration of S raised to power n, and then for P raised to power x and Q raised to power y in that order like that. So let's take note of that. Very, very important. All right, so this one says that which of the following reaction is an oxidation process? Which of the following reaction is an oxidation process? Is it option A? Is it option B? Is it option C or option D? So the right answer is option B. And the reason is because oxidation involves the loss of electrons or increase in oxidation number. And you can clearly see this in our option B. There's a loss of electron. We are transiting, there's a loss of electron and then there's an increase in oxidation number. How did we know? Look at it. Oxygen there is moving from like a minus 4 or minus 2, they're about to up to 0, and then there's a loss of electron. 4 electrons have been lost, that's for us to have the oxygen, that atom that is being formed as the product there. So this is an oxidation process. Okay. If acidified potassium dichromate 6, that's K2Cr2O7, acts as an oxidizing agent, the color changes from, is it yellow to green, orange to green, yellow to red, orange to red? So the color would transit from orange to green. That's the transition of the color. And the reason is because acidified potassium dichromate is orange in color when it acts as an oxidizing agent, e.g. oxidizing alcohol to ketone. The Cr6 plus is reduced to Cr3 plus, which is green in color. This characteristic color change from orange to green is used in redox titration. So let's take note of that. Very, very important. Okay, moving along now, and then we look at question 27 that says that the heat of formation of ethene is plus 50 kilojoule per mole, and that of ethane is minus 82 kilojoule per mole. Calculate the heat evolved in the process. So we need to do some basic calculation there. And we have the equation there. We have the heat of the reaction. It's an exothermic reaction, losing out minus 122 kilojoule of energy or heat, in the environment. So, so our options, what are our options? We are given that. So the right answer to this one is minus 132 kilojoule per kilojoule. And how did we come about this? It's just basically this. Delta H reaction equals to delta H of formation for products minus delta H for formation for of reactants. And when you have this, you have what? Our minus 82 minus 50 plus 0. So when we look at it critically, that will be equals to minus 132. So 132 of 132 kilojoule of heat is released in the hydrogenation of ethane to ethane. Okay. The next one says that which of the following statements about catalyst is false? Is it A? Is it B? Is it option C? Is it option D? So let me know in the comment section which one you feel is the right answer. Okay. And the right answer to this one is option D. Catalysts do not alter the mechanism of the reaction and never appear in the rate law. And this statement is false because catalysts do alter the reaction mechanism by providing an alternative pathway with lower activation energy. Also, catalysts can appear in the rate law, especially in complex or enzyme catalyzed reactions. So D is incorrect and is therefore the correct answer to this particular question. This one says that which of the following does not support the fact that air is a mixture? A, the constituents of air are in a fixed proportion by mass. It cannot be represented with a chemical formula. The constituents of air can be separated by physical means. D, none of the above. So the answer here is that the constituents of air are in a fixed proportion by mass. So this is which of the following does not support the fact that air is a mixture. The answer there is option A. And the reason is because air is a mixture, not a compound. Its components, oxygen, nitrogen, carbon dioxide, etc., are present in varying proportion, not fixed one. It cannot be written as a chemical formula, and its constituents can be separated physically. Only option A is incorrect about A. Hence, it is the right answer. Okay, so what technique is suitable for separating a binary solution of potassium chloride and potassium trioxochlorate 5? Do we use fractional crystallization, fractional distillation, filtration, or evaporation? And the right answer to this one is fractional crystallization. Why? The reason for it is because potassium chloride and potassium trioxochlorate 5 are solids that differ in solubility at different temperature. Fractional crystallization separates such mixture by cooling their solutions gradually. The less soluble compound crystallizes out first. This method is suitable for two solid solutes in the same solution. Okay. At 27 degrees Celsius, 58.5 grams of sodium chloride is present in 250 cm cube of a solution. What is the solubility of sodium chloride at this temperature? Note that the molar mass of sodium chloride is 58.5. So we have our options there. So let me know in the comment section which one you feel is the right answer. And the right answer is 4 mole per dm³. How did we arrive at this? Mass of sodium chloride is 58.5 grams. And then the volume of solution is 200 cm cube, which is about 0.250 dm³. That's 250 cm cube divided by 1,000. So that's converting it to dm³. Then the molar mass is 58.5 gram per mole. Now, if that is the case, the first thing that we are going to do is to try to calculate the number of moles of sodium chloride that is present. So that will give us moles equals to mass divided by molar mass. That's 1.0 moles. The second step is to calculate the solubility in mole per dm³. And don't forget that solubility is mole divided by the volume in dm³. We've arrived at a volume of 0.250 dm³ from our question where we were given 250 cm³ and we converted it to dm³. So basically, solubility is 1 divided by 0.250, which will be equals to 4.0 mole per dm³. 4.0 mole per dm³. Okay. All right. See. However, okay. Yes. Okay. I need to state this. However, this value 4.0 mole per dm³ is not among the options. Let's recheck the problem. If 58.5 gram is dissolved in 250 cm³ and 58.5 gram is 1 mole, then yes, we have 1 mole in 0.25 dm³, which means solubility should be 4.0 mole per dm³. So the answer is not there. And this is the right answer based on our calculation. So please let's take note of that. And you may have to leave this one out if you see a question like this in JAMB, okay, and don't shade anything. All right. So which of the following properties increases from left to right across a period, but decreases down a group in a periodic table? Or in the periodic table, is it atomic number? Is it ionization energy? Is it metallic character? Is it electron affinity? So what are the options? 2 and 3 only, 2 and 4 only, 3 and 4 only, 1 and 2 only. So this was just about, trends on the periodic table. So let me know what you feel the right option is in the comment section, please. While I move along and tell you that the answer to this one is B, 2 and 4 only. The reason is because ionization energy increases across a period due to stronger nuclear attraction. So it decreases down a group, but increases across a period. Electron affinity becomes more negative across a period, but it decreases down the group. Metallic character decreases across a period, while it increases down the group. Atomic number always increases. It does not vary periodically. Thus, correct option is what? 2 and 4. 2 and 4, which is ionization energy and electron affinity. Okay. This one says that the molecular shape and bond angle of water are respectively linear, 180 degrees Celsius, 180 degree, bent, 109.5 degree, tetrahedra, 109.5 degree, then bent, 105 degree. Now, the answer is D. It is bent, it is 105 degrees. Water has two lone pairs on the oxygen atom, which repel the bonded pairs, causing the bent or angular shape. The bond angle is approximately 104.5 degree, so about 105 degree less than the tetrahedra, which is 109.5 degree due to lone pair repulsion. Okay. So the next question says, looking at this equation, the indicator most suitable for this reaction should have a pH equal to, is it A, B, C, or D? The answer is it's B, 7. Should have a pH equal to 7. And the reason is because this is a neutralization reaction between a base, carbonate, and a strong acid, HCl. The solution at the equivalent point is neutral. So a neutral pH of 7 is expected. So an indicator like methyl orange or bromo-thymol blue, which changes near pH 7, will be much suitable. So okay. A radioactive nucleus has a half-life of 20 years, starting with 100,000 particles. How many particles remain after 40 years? Is it A, option A? Is it option B, option C, or option D? Okay, now the answer is 25,000 particles. How did we arrive at that? After one half-life, which is 20 years, 100,000 will become what? Will reduce by half to 50, right? After two half-life, which is 20, which is another 20 years, so it's 20 plus 20, that's 40 years now. The 50,000 will have reduced again by half. So C, 25,000 particles will remain after 40 years, okay? Which two gases can be used for the demonstration of the fountain experiments? Is this SO4 and NH3, SO3 and NH3, HCl and NH3, or SO2 and CO? Okay, so the answer to this one is HCl and NH3. And the reason is because the fountain experiments illustrates high solubility of gases such as HCl and ammonia in water. When water enters the flask containing either of these gases, it dissolves rapidly, reducing and causing a fountain effect. These gases are highly soluble and acidic or basic, making them ideal for these experiments. Okay. Which of the following pollutants will lead to the depletion of the ozone layer? Is it chlorofluorocarbon, carbon 2 oxide, hydrogen sulfide, or sulfur 4 oxide? The answer is chlorofluorocarbon. Chlorofluorocarbon, that is A. CFCs, which we call chlorofluorocarbon, release chlorine radicals in the stratosphere, which breaks down ozone into oxygen. This results in ozone depletion, allowing harmful UV radiation to reach the Earth's surface. CO and SO2 are pollutants, but they do not deplete ozone directly, and that's just it. So CFCs, that's chlorofluorocarbons, are the pollutant that leads to ozone depletion. Okay. This one says that which of the following describes the chemical property of acid? A is none of the above. B is acid plus XCO3 to give us salt plus water plus NH3. Acid plus NaOH give us normal salt plus CO2. Acid plus XNCO3 to give us salt plus water plus CO2. So the option is option D. And why did we say option D? Is because acids react with carbonates to produce salt, water, and then carbon dioxide. This is a classical acid carbonate reaction, which demonstrates a typical chemical property of an acid. Okay. All right. Other options, nah, but that B, correct. Okay. Which of the following pairs cannot be represented with a chemical formula? Is it A and bronze, bronze and sodium chloride, copper and sodium chloride, or caustic soda and washing soda? The answer is air and bronze, and air and bronze are both mixtures. Air is a mixture of gases. Bronze is an alloy of copper and tin. Mixtures and alloy do not have fixed formulas. Sodium chloride, caustic soda, and washing soda are compounds with definable formulas. Thus, air and bronze cannot be expressed with chemical formulas. Okay. Okay, the 40th question says, consider this equation. The oxidation number of chromium changes from what? Is it plus 5 to plus 3, plus 6 to plus 3, minus 2 to plus 3, or plus 7 to plus 3? So the answer to this one is a plus 6 to plus 3. And the reason is because Cr2O7 to minus oxygen is minus 2. Total oxygen will be 7 times minus 2, which is minus 14. To balance the charge, let's see R equals to X. So 2X minus 14 equals to 2. And then 2X equals to 12. When you take the 14 to the other side. So X will be equals to plus 6. So in the product, CR is plus 3. So CR is reduced from plus 6 to plus 3. So that is that for that. All right, see? Okay, which of the following is a physical change? Exposing white phosphorus to air, burning kerosene, dissolving calcium in water, or freezing ice cream? The physical change that we have there is freezing ice cream. Okay, physical change do not alter the chemical composition of a substance. Freezing is a change of state from liquid to solid, which is reversible and involves no chemical reaction. Other options involves chemical reactions, e.g., burning, reacting, oxidation, and so on and so forth. In the reaction between sodium hydroxide and tetraoxosulfate 6 acid, what volume of 0.5 molar sodium hydroxide will exactly neutralize 10 cm cube of 1.25 molar H2SO4? So when we look at it, the right option is A, and it's based on this calculation that we have here, using M1 V1 over N1 equals to M2 V2 over N2, slotting in the values individually, then looking for the unknown, which is V2. You arrive at a volume 2 of V2 of 50 cm cube. Okay, sulfur exists in 6 forms in the solid state. This property is known as isomerism, allotropy, isotopy, isomorphism. And the answer to this is allotropy. Allotropy. So allotropy is the existence of an element in 2 or more different physical forms in the same physical state. Sulfur has multiple solid allotropic forms, e.g., rhombic sulfur, monoclinic sulfur. So isomerism is just like a different arrangement in compounds, and that's why it's not the right option. Isotopy, atoms with the same proton number but different neutron number. Isomorphism, on the other hand, is similarity in crystal structure between different compounds. So it's allotropy is the right answer for us. Okay. Okay, in the reaction, and that's the reaction that we have there on the screen. Which of the following will increase the concentration of the product? Which of the following will increase the concentration of product? Is it A? Is it option B? Is it option C? Or option D? So let me know what you feel the answer is there. Okay, option C, increasing the temperature. The reason is because the reaction is endothermic. Um, that is, it is absorbed. According to Le Chatelier's principle, increasing temperature favors the endothermic direction, forward reaction here now. So more products P is formed. Catalyst speed up the reaction but does not affect yield in any way. Okay, so a compound contains 40% carbon, 6.7% hydrogen, 53.3% oxygen. If the molar mass is 180, what is its molecular formula? What is its molecular formula? Is it option A, option B, option C, or option D? Okay. The right answer here is actually option C, which we have there. And how did we arrive at that? Step one, convert percentage to moles. So 40% divided by 12 will give us 3.33. Abi? Okay, 6.7% for hydrogen divided by 1 will give us 6.7, then 53.3 divided by 16 for oxygen will give us 3.3. So we divide by the smallest, by the smallest, which is 3.33. So when you do that, you have a ratio of carbon 1, hydrogen 2, and oxygen to be 1. If that is the case, the empirical formula will look like CH2O. That's the empirical formula, whereby the empirical mass equals to what? 12 plus 2 plus 16, okay, which equals to 30, which equals to 30. Now, molecular mass is 180. 180 divided by 30 will give us 6. So the molecular mass basically would be what? CH2O into bracket 6. That will be C6 H12O6. And that was how we arrived at that particular answer. Thank you. The IUPAC nomenclature of the compound H3C, CH, CH3, CH, CH3, CH2, CH3. Is it 3,4-dimethylhexane? Is it 2,3-dimethylpentane, 2-ethylhexane, or 2,3-dimethylhexane? The answer to this one is 2,3-dimethylpentane. And let the number from the left, that is the longest chain. Let's number from the left, pardon me, that is the longest chain. So we have 1, 2, 3, 4, 5. So it's pentane backbone, 5 carbon atoms, okay? Therefore, the name is what? 2,3-dimethylpentane, because the methyl group or the methyl group is on position 2 and position 3 accordingly, okay? Which of the following gases contain the least number of atoms at STP? Is it option A, option B, option C, or option D? So which one contains the least number of atoms at STP? The answer is option D, 7 moles. How do we arrive at that? We count atoms per mole. So butane, C4H10 would be what? 14 atoms multiplied by 1 mole. Right? 14 atoms per mole. Chlorine is 2 atoms per mole. That's 4 moles multiplied by 2. That's 8 atoms per mole. Oxygen, 3 atoms per mole, which is 3 moles multiplied by 3, which will be equals to 9 atoms. Then argon is monoatomic, 1 atom per moles. And that would be what? 7 moles multiplied by 1, which is 7 atoms. So thus, argon has the least number of atoms in that particular question. What mass of magnesium is obtained by passing a current of 2 amperes for 2 hours, 30 minutes through molten magnesium chloride? We're given these parameters. 1 Faraday equals to 96,500 coulombs, and then magnesium is 24 relative atomic mass. Okay, so the options are 1.12 gram, 4.48 grams, 1.80 gram, or 2.0 grams. So when we calculate, our right answer will be 4.48 grams. How did we arrive at these? No, to calculate the mass of magnesium deposited by electrolysis, what we start off is, what were we given? We're given a current of 2 amperes. We are given a time of 2 hours, 30 minutes. We're also given a molar mass of 24 gram per mole, and then the number of electrons to be 2, since magnesium Mg2 plus will give us plus 2 electrons, we give us then to deposit magnesium. So 1 Faraday is 96,500 coulomb per mole. So having given us all this, we can now calculate how um, the mass of magnesium that is obtained. So calculate the total charge, which is Q. Q equals to IT, which is 2 times 9,000, 2 times 9,000. 9,000 is the time, 9,000 seconds now. So that'll be 18,000 coulombs, okay? Then the next one is step 2, apply Faraday formula for mass deposited. So mass is equals to the Q multiplied by M divided by N multiplied by F. So our Q multiplied by M will be 2 times 9,000 times 24, which is the mass that was given to us, divided by 2 multiplied by 96,500. So approximately we'll be having 4.48, 4.48 grams as the mass of the magnesium. Okay, this one says that which importance, just a minute, please. Okay. Which important nitrogen-containing compound is produced in Haber process? Which important nitrogen-containing compound is produced in Haber process? Is it A, ammonia, B, nitrogen 4 oxide, nitrogen 2 oxide, or HNO3 nitric acid? So the answer to this one is actually A, ammonia. And the Haber process is used for the industrial production of ammonia. It uses ion catalyst at high pressure and moderate temperature. Okay. Elements in the periodic table are arranged in the order of their atomic numbers, metallic character, mass number, relative atomic mass. And the answer is atomic number. That's correct. So modern periodic table states that the properties of elements are a periodic function of the atomic numbers, number of protons. Earlier arrangements, Mendeleev used atomic mass, but anomalies led to the adoption of atomic number as the correct basis. Okay. So that's that for that. So with this, I think we can call it a wrap. And I want to say thank you for going through these past questions with me, or this past question with me. We'll also be looking at more of them as we go along. So I'll see you again in the next video. Thank you. I'll see you shortly.